Greetings, my name is Andre Cerezari, and this is part 3 of my conceptual design of an ultrasonic test equipment. And in part 3, I will discuss the mechanical concepts for this conceptual design. There's 4 main designs that were considered for this automated equipment. First, there is the gantry. Uh, there is also the crane, a mobile platform, and lastly there is a combination with an undercarriage. The first concept, which was the gantry had the transducers overhead uh, above the test piece. And one of the main advantages of this type of system was that it was easy to program. The rails, one would be on top of the gantry, and then the others would be along the length of the test piece. They would be easy to program because the rails would act as X and Y axis. And also this would be easy to implement with pitch catch sensors. So one sensor could send a signal while the other could receive it. The disadvantage of this particular system would be that there would only be one rail with both of the transducers on it. So all the tests would be along the y-axis. So subsequent tests could be taken in the x direction, but they would all be in the y-axis. In the crane, which was similar to any crane that you see on a building, it was just an overhead system which carries either one or two transducers, and then it moves around the test piece. One advantage to the system was that an operator facing from the far side would have easy access to the test piece in case any work needed to be done on it. Also, there would be a little more, there could be possible more flexibility in the positioning, but a big disadvantage in this kind of system would be that there would be no intuitive programming. Rotation, possible extension here would have to be considered for programming this take test. Another concept which might be interesting from a research standpoint would be a mobile platform. One of the big advantages of a mobile platform would be its possibility for field uses. So this particular platform was very similar to the gantry, which was given 4 wheels, and this would probably be good for use on larger samples. A disadvantage of this type of mobile platform would probably be the likelihood for tethering. Uh, Tethers could possibly get stuck on the test piece, and uh, location would have to be more carefully controlled. For this particular design, slipping could be a very big issue. The last concept was a combination of the previous concepts here. Just a gantry was placed on a mobile platform, and an undercarriage was placed on a rail system. And one of the advantages of this type of system would be that through transmission could be done with one transducer right above the other. A disadvantage would be that the undercarriage would have to require a very compact design, and a lot of care would have to be taken into consideration to make sure that this is in a small enough and very mobile spot so that it doesn't move a test piece off its stand. As far as methods for getting the couplant and the transducer to bond or to be together, there was 2 techniques that were considered. First was the immersion technique, and second was the dispenser, the creation of a dispenser. For the immersion technique, it was a big advantage to it was the ease and automation. There was basically an assured contact between the couplant and the test piece, because it would basically both of them would be under the the bath here, or the couplant. A big disadvantage would be the need for waterproofing of the equipment. A big advantage of the next concept of the dispenser would be the portability. If, say, a mobile platform were used, this kind of dispenser could be used on that mobile platform, and no gigantic bath would be needed to place the test piece inside. But the big disadvantage would be no guaranteed contact. A lot of work would have to be done to assure a guaranteed contact between the transducer and the test piece. The final recommendation that I suggest would be two independent gantries. Here, to make sure that they don't cross each other, there would be a safety stop switch. Uh, each gantry would have its own receiver or, or transducer, and each one could be operated independently, which would allow for the reception to be the, the reception for the transducer to be anywhere on this test piece. Also, the immersion technique was recommended to make sure that the contact between the couplet is assured, and also all screen displays are recommended for use.